In this video, we're going to look at an example that requires us to change the order of integration in order to be able to evaluate the iterated integral. So in this one, we have the integral from 0 to 2, integral from y over 2 to 1 of y cosine of x cubed minus 1 dx dy. The reason why we can't integrate this the way it's presented to us is because I would really want to do this with a u substitution and let u equal x cubed minus 1. However, the derivative, 3x squared, is nowhere to be found. So I'm not going to be able to integrate this with respect to x first. However, we notice that we can integrate it with respect to y first pretty straightforwardly because all we would need to do is integrate the y piece. So that tells us that we probably want to reorder the integration and see if we can get an easier integral. All right, so first I notice that we have x equals y over 2 as one bound and x equal to 1 is another. Well, x equal to 1 is easy to graph. That's that vertical line. X equals y over 2 can be rewritten as y equals 2x, so that's this slanted line here. Now if we choose to integrate with respect to y first, that means we hold x constant, and we know the y's go from 0 to 2x. And we also now notice that our x's go from 0 to 1. So now we're ready to do this integral by setting it up in the other order. So our y's again go from 0 to 2x, so those will be our inner bounds, or inner limits of integration. And then the x goes from 0 to 1, and so the 0 and 1 will be our outer limits of integration. Antiderivative for y is 1/2 y squared. We're evaluating that function from 0 to 2x, so now when we plug in those endpoints, we get 2x squared cosine of x cubed minus 1. And now, remember, we really wanted to try to do that original problem using a u substitution. We didn't have an x squared for the du to start with, but now we do. So now if we let u equal the inside, du will be 3x squared, so that's where the 2/3 is coming from here. Antiderivative for cosine is sine, so we get 2/3 sine of x cubed minus 1. Plug in your endpoints and evaluate, and you'll get 2/3 sine of 1 for your final answer.